In this video, we're going to look at the simplest way to sketch a quadratic graph if our function is in vertex form. So what do I mean by vertex form? Well, if our equation looks like this, y equals ax minus h squared plus k, then it's in vertex form. If it looks like this or similar to this, close to this in any way, it's in vertex form. And there is an easy way, a simple way, to figure out what the vertex is and to see some things about the graph. But first and foremost, we need to remember the shape of a quadratic graph. So a quadratic graph, if we were to do a t-chart, like back in the day, and look at different x values, we have, let's say, from -3 to 3. So -3, -2, -1, 0, 1, 2, 3. So these are the values on the x-axis that I would like to see. So I'm going to draw a nice big quadratic graph here. So I want to see 1, 2, 3, 1, 2, 3. And this is not going to be a good looking graph, but I'll try my best. All right, 1, 2, 3. All right, so if we're doing the graph of x squared, so really y equals x squared, the simplest quadratic graph that I can draw, I'm going to square all the values in this chart. So -3 squared would give us +9. We get a +4 here. And then it cycles back up 1, 4, and 9. So our graph, 1, 2, 3, 4, 5, 6, 7, 8, 9, would look like this. There would be a point at 0, 0, 1, 1, 1, 1, 2, 4, about there, 2, 4 about here, and 3 goes with 9, and up here, and then you connect all those wonderful, beautiful dots, and it would form a shape called a parabola. Not too shabby. All right, so here's the point. I drew the parabola because I wanted you to see it. Basically, we're going to take that parabola and we're going to start moving it all over the place. We're going to move it up and down, left and right, flip it over, all kinds of good stuff. So let's see how this works. All right. Okay, so just to remind you, the graph of y equals x squared looks like this. It's the simplest quadratic graph we can see. Now, let's say there is a number in front of the x squared. And let's say, first of all, let's say that number is negative. All right, so I'm going to draw the simplest graph over here. And we'll see how it can change. I'm doing a terrible job, but this should go to 0, 0. Okay, so that's the graph of y equals x squared. If we make or a negative, so if we have, for example, y equals negative ax squared, then what's going to happen is the graph is going to be flipped about the x-axis. So it's going to be flipped upside down, and it will look like this. Well, again, there we go. Kind of like that. It will be a mirror image of the blue. So that's the graph of y equals negative. This is actually the graph of y equals negative x squared, because I flipped the graph of negative x squared. All right, let's do another thing here. Let's talk about what a number, let's say a number greater than 1, what would that do to the graph? So let's say y equals 2x squared. All right, if I have y equals 2x squared, this graph is going to be climbing twice as fast. So if the graph is climbing twice as fast, then you would get a narrower graph. So it would look like this. So this graph is climbing twice as fast, and that's the graph of y equals 2x squared. Now, similar idea down here. If I flip that graph, it gets narrower and negative. So that's the graph of y equals negative 2x squared. So what then do you think would happen if let's see. I wish I had another color here. Let's try and find one. Okay, we do. All right, let's see. What would happen if we had y equals a half x squared? What do you think would happen? Well, if you said it would be climbing half as fast, you are correct, which would mean that the graph is, in fact, wider. So here, with the 2, it was narrower, and the half, it's wider. All right, so the graph of y equals a half x would probably look like this. All right, a half x squared. All right, so let's make sense of all this craziness I have going on this page, because I know this looks a little bit messy. So what do you need to take from this? So first of all, negative a flips the graph upside down. So it will be upside down if or a value is negative. What else should you take from this? If or absolute value of a is less than 1, so if we have a fraction, let's put that there. So we're just saying if or a value is a fraction, then our graph will be wide. But if our a value is more than 1, so it's a bigger number than 1, then our graph will be narrow. And that's actually opposite to what most people would think, but hopefully you see why that's the case. So that's the 3 things I want you to take from this so far. Let's keep going though. Okay, great. So now we have a nice new clean page, and now we can talk about moving the graph left or right. So in order to move our quadratic graph left or right, we're going to have to add or subtract within parentheses. So let's talk about moving left first. To move left, we have to add within parentheses. All right, and I'll show you exactly what I mean by adding within parentheses. So let's say, for example, we have a graph y equals x plus 2, and all of that is squared. So now we're adding within parentheses. Whenever you see that addition within parentheses, that's an instruction. That's an instruction that's telling you to move your graph over to the left. So now we're going to move our graph to the left. So before, our vertex was on 0, 0 for our simplest graph, y equals x squared. Now we're going to move to the left 1, 2 positions, but the shape of the graph will remain the same. It's not wider or thinner because we don't have a value here. If we did, it would be wider or thinner, but we don't, so that's okay. All right, so then the graph, or new graph, would look like this. And this is just a very rough sketch, but the vertex is the thing that I want to show you that has changed. So now the vertex of our new graph would be negative 2, 0. We could do this again. We could move the graph right if we want to. All right, so let's use a different color. And let's say we want to move the graph right. Well, when we added in parentheses, it moved the graph left. So when we're subtracting in parentheses, that's what it would take to move the graph right. So we're going to subtract in parentheses. And what that looks like, for example, is y equals x minus 1 squared. Again, that's the direction to move the graph to the right. So we're moving it right. So now, instead of our vertex being at 0, 1, it's moving to the right 1, and our new graph, and again, this is just a really rough sketch, but what really matters that you understand is that the new vertex would be 1, 0. All right, so the last motion that we're going to look at is moving the graph up and down. After that, we can put it all together. So how do we move our graph up or down? Well, adding we'll move the graph up, but this time it's not within parentheses. It's either outside of parentheses or no parentheses. So adding outside of parentheses or no parentheses moves the graph up. And I'll just put an arrow. All right, which means, for example, if we have x squared, so notice that the x is squared, it's not x plus anything squared, it's just x squared, plus 3. So y is equal to x squared plus 3. This is telling us that we need to move a graph up. So it moves up 3. So we have here, right now it's at 0, 0. Then we go 1, 2, 3. We're moving the graph up, and it's the same shape, but it's moved up. So it would look a little something like this. And again, this is really a very rough sketch, but this is the graph of y equals x squared plus 3. What's really important is that you see where the vertex went to, from 0, 0 up to 0, 3. Or we could move the graph down. And let's see, did you guess how to move the graph down? I think you did. Subtracting outside of parentheses or with no parentheses moves the graph down. Okay. Moves the graph down. So I'll just put an arrow. So for example, if we have y equals x squared minus 2, you'd have 1, 2, and then the graph would be right there. And not sure how good a job I'm doing, but again, what really matters is that the vertex, I know, has moved down to 0, negative 2. All right. Well, this doesn't become very interesting until you start seeing it all together. So let's do an example and then call this one complete. Okay, so all kinds of instructions are in this function. So this half tells us that the graph is slightly wider than the normal y equals x squared. This negative sign tells us that the graph is flipped upside down. Having a plus 3 in parentheses tells us that the graph is moved to the left, and having a minus 1 outside the parentheses tells us that the graph is moved down. So there's a lot going on here. The first thing that I would want to do, and I'm going to do this in a really light color, hopefully we can see it, is I'm going to draw the graph of y equals x squared. And I think I'm getting slightly better at it. Alright, that is not the answer, which is why I drew it in a really light color. I'm going to pick another really light color, and I'm going to flip the graph upside down and make it wider at the same time. But again, it's not the answer. It's just the instruction that comes first. Flipped and wider. So I'm flipping it and I'm making it slightly wider. And that's the graph of, or sketch of the graph anyway, of y equals negative a half x squared. But we have a lot more stuff to do with this graph before we're happy with it. Let's label this so we don't forget what that was. Y equals x squared. All right. We're also told that we need to move the graph to the left and down. Let's move it to the left first. I'm going to make the color slightly brighter because we're getting closer to the answer. So the vertex is 0, 0 right now. 1, 2, 3. Now that's the new vertex. The shape stays the same as my light purple graph. And that is not the answer yet. That's the graph of y equals negative a half x plus 3 squared. Now we're still told here that we have to move the graph down 1. So the vertex is now going to be, and I'm going to make this big and bold, nice and blue, so we know that this is the answer. So we're moving our vertex down 1. So our vertex is actually here at, I'll write it down, at -3, -1. All right, so quick shortcut here in order to figure out the vertex. You may appreciate this. Remember that our equation in vertex form was y equals a x minus h squared plus k. Well, in this particular example, our a was -1/2. That doesn't really help us with the vertex, but the rest does. X minus, all right, if you check it out here, we have a +3. So that means we're actually subtracting -3 here. So x minus -3, I'm just trying to get it in this format, squared plus, and here, check it out, we have a -1 here. So we're adding -1. So our h value is -3 and our k value is -1. That's actually the vertex. The vertex will always be given by h comma k. Nice little shortcut so we don't have to dance around, draw the x squared, flip it upside down and move it over, and it's kind of this big dance that we don't necessarily have to do all the time. So if you're just asked to find the vertex, we can figure out what h is, figure out what k is, and we're good to go.